We're just going to start with a quick introduction to the EU for Ocean Coalition, which is the reason why we're all here today. And then I'll pass the microphone over to our moderator for the day to introduce our panelists. So just to kick us off, as mentioned, we're here for EU for Ocean. And EU for Ocean is an initiative that's supported by the European Commission and was started back in 2020. And the point of EU for Ocean is to promote ocean literacy across Europe and across the world. Why stop at Europe? There are 3 different communities involved in EU for Ocean. The first is the EU for Ocean platform, which is a catalogue, a place to meet, a forum of many different entities in Europe who are interested in ocean sustainability and ocean literacy and raising awareness about the ocean. There's also a pillar that's dedicated to Youth for Ocean, and this brings together the young voices from Europe, again with similar aims to be advocates for the ocean and to promote ocean awareness and sustainability. And then the final branch is the network of European Blue Schools that works with the youngest citizens of Europe, again to bring the ocean into their daily lives. At the moment, there are over 1,000 members in the network. So this network is growing every day. And you saw at the beginning of this presentation, and you'll see again at the end, a QR code where you can go online and join the community. This is a very active community with activities going on all over Europe. All the time, there's something going on somewhere. And with the summer coming, this is a very good time to sign up to be part of the coalition. And what can the coalition do for you? Well, the coalition, it's a community first and foremost, where you can share ideas, learn from other people, get support for your initiatives, raise visibility of your initiatives. You can understand how ocean literacy and ocean sustainability and awareness can influence policy, local and at European level. And you can also learn new things and take part in new activities maybe that you weren't aware of before. So again, here is the QR code if you'd like to join. We'll show it again later. This webinar, I should also say, will be available online in about a week or so after the event. And it's available through the EurOcean.org YouTube channel. Okay, if you'd like to join our LinkedIn group, again, we have here another QR code, so you can just scan the code, join the group, and this is the best way to be kept in touch about most recent happenings in the EU for Ocean Coalition at any given time, okay? It's permanently updated and it's very active, so I think this is a good place to start in joining the coalition. With that said, I'll hand over to Ned. Our reason for being here today, obviously, is to discuss how ocean literacy and European business can work together, and in this case, towards the marine renewable energy sector. So, hello, Ned. Welcome, and thank you for being here. I'll shut up now and turn off my microphone.
Thank you very much, Ruth, for the introduction and the overview of the EU for Ocean initiative. It's a really fascinating one, and it's great to see that it's kind of in so many places across Europe and that it's having such an impact. So good afternoon to everyone that's here on the webinar. My name is Ned Dwyer. I'm a consultant with RANBI, an SME based out of Spain. And in the company, we focus on statistical analysis, web visualization techniques, spatial modeling, artificial intelligence, and capacity development, mainly in relation to environmental data, so land, ocean, atmosphere, and beyond. Now, my own personal background is in satellite remote sensing. I worked for many years at University College Cork in Ireland, where I crossed paths with Brendan Cahill, who's one of our speakers today. And I'm also a former executive director of EurOcean. So it's a real pleasure to have been invited along here today to act as moderator of this session. So let's get started with the main business of the day. As Ruth said, today we're focusing on the renewable energy industry and kind of its nexus and how it connects with ocean literacy. So that's really what our focus will be on. So the webinar lasts about an hour or so. So the plan is we have two great speakers today, each of which will give a 15-minute presentation, and then we'll have a Q&A session afterwards. So what I would say to you as both Brendan and Dennis are speaking, if questions come to mind, please use the Q&A facility that you have in Teams and post your question in there, and we'll do our best to ask those questions afterwards. If you want to wait until after you've heard the presentations, that's okay too. You can then also post your questions. So whatever is best for you. So let's get started on the real meat of the day. So it's a great pleasure for me to introduce our first speaker, who will be Brendan Cahill. And Brendan is the Director of Development at ORPC, which leads business and project development activities in Europe and other global markets for ORPC Ireland. And that company is a developer of tidal and river hydrokinetic energy technologies. Brendan himself has 15 years of experience in the ocean energy sector, with past roles in the public sector, in consultancy, and also academia. He completed a PhD in ocean energy resource characterization at University College Cork in Ireland, and that's where our paths briefly met when we were both there together. And he was previously a Fulbright scholar at Oregon State University in the United States. So, Brendan, I'm going to hand over to you now. You have 15 minutes. So, after 12 minutes, I'll just kind of break in orally to the session to let you know you have about 3 minutes left. So, Brendan, over to you.
Great, thanks, Nate. Pleasure to speak to you all this afternoon. I'm going to focus on ORPC and our perspectives around ocean literacy as a developer of ocean energy technology and projects. And I'm going to start maybe by just introducing our company and then the types of projects we're working on, and come back then about and talk about how, as we engage with different stakeholders, the concept of ocean literacy really cross-cuts those interactions. So a bit about ORPC. We're a US headquartered company headquartered in Portland, Maine, on the east coast of the US, but we are spread globally across Canada, across the rest of the United States, Chile, in South America, and then in Ireland, where ORPC has had a subsidiary going back 10 years this week. Actually, was our anniversary of setting up in Ireland, and we have a team of 6 people who lead our European technology research and development work, and then also business development, which I'm focused on. So our focus at ORPC is on converting the kinetic energy that's in flowing water, be it in rivers, estuaries, tidal currents, and turning that into affordable and predictable renewable electricity. And that is both developing the technology, the projects to harness this resource, and then also the supporting infrastructure, things like the wider smart microgrid needed to bring a community that had been off grid and reliant on things like diesel generators for electricity, bringing that full package of a clean energy system to those communities. And so our objective is to work with those communities and also other users, like operators of critical infrastructure, businesses, a wide range of different applications, but developing those projects to meet their needs, and their particular needs dependent on their situation or their location, but then also ensure that as we develop these projects, we can leave a wider benefit, including creating jobs locally, be it during the installation phase or the ongoing operation of projects. And here you can see just an example of one of our systems, our RivGen system, and this, I guess, patented cross-flow turbine system, which is common across our technologies, and how we convert that energy in free-flowing water into electricity. A bit about I'll talk maybe firstly about our projects in North America, which I think give a good sense of the range of projects we're developing and what we're trying to replicate in other markets across the world, including in Europe. So our flagship project is called the Igiugig Hydrokinetic Project. This is a river-based system in Alaska, working with the community of Igiugig, who we've been engaged with for over 10 years. And we've had 2 of our RivGen devices installed in Igiugig. We've 2 installed now, but we've had individual devices installed since 2019. And here you see the 2 devices in the river. The one on the bottom right-hand corner is a device sitting underneath the surface of the water, sitting on the riverbed, connected back to the shore by a cable and generating power from the rotation of that turbine. And then on the surface, you see the second device, which is getting ready for installation. And this is, being towed out by small local vessels using local supply chains. So we think this is a really good case study of a project, focused on remote off-grid communities. Igiugig had been reliant completely on diesel generators for power and their sources of energy before the development of this project. And now with these 2 units in place as part of a wider smart microgrid, we can look at significant reductions in the usage of diesel generators and the associated emissions from those. Scaling up from that project, we are now working with the Alaska Village Electric Cooperative, so an amalgamation of many similar communities to Igiugig. And as part of a funded project, we're doing a wide-ranging feasibility study looking at how we could replicate the example of Igiugig across the state of Alaska, both in river settings and also tidal environments on the coast. And this was, included a lot of engagement with these communities to understand their needs and understand their local resources, and starting to complete the work around assessing that resource. And we've been doing that since 2024. This summer, we're starting a lot of the field work with the sites we've identified as being the highest priority, and then looking at going on and expanding with device deployments from 2026 onwards. But this is an example of, again, how this type of technology, and this is just one state in the US, but how we can replicate this on a wider scale. And then similarly in Alaska, focusing on the tidal environment, and something particularly relevant to many European markets like France, the UK, parts of Ireland, where we have significant tidal resources. Through a US Department of Energy project, where we've been awarded funding to develop a multi-megawatt tidal energy array in Cook Inlet, which is probably the prime tidal energy resource in the United States. So over the past year, we've been working on the initial stages of this project with the hope of securing additional funding as part of the down select for that project. But this has included both understanding the resource at this site, but also understanding how we can develop a local workforce, enhance community engagement, and then also study the interactions with other users of the marine environment and the existing species that are resident in the area. So it's been a very wide-ranging project covering both the technical and the socioeconomic. And now, so that's the scale of the projects we're doing in the US, and I'll talk about now how we're trying to replicate some of that work in Europe. And as I said, we've been active in Europe for over 10 years with a very strong focus on technology development and R&D. And the video here is some of the testing we carried out as part of a European Commission funded project called Crimson we completed in 2024. This was taking one of the turbines that you would have seen on the RivGen device in Alaska and testing it at the CNR towing tank in Rome in Italy. And this worked with a range of partners across Ireland, Italy and Germany to look at how we can improve the performance of this turbine and also reduce the environmental impact in terms of having a more optimal design and using recycled materials in that device. And this was, cross-cutting expertise across material science, our own expertise, and working with large industry and also universities to complete this testing and develop new solutions for this type of technology. Really valuable project, and it secures some really important data that helps the in-water deployments like those in Alaska I mentioned previously. We went on from that project then and took that same turbine and deployed it in Strangford Lough in Northern Ireland at a test site operated by Queen's University Belfast. This is a long-running test and demonstration area for tidal energy. It was home to a grid-connected tidal energy device for many years, one of the first in Europe, and then also has been home for testing various devices. So it's been a real test bed for tidal energy in Europe, and as well as the technology development aspect, I think has been very important in terms of what's been learned about community engagement due to the long-running nature of this test site, and also interactions with the wider marine environment. So that turbine was tested in Strangford Lough at the end of 2024. We mounted it on a barge, not maybe our normal configuration, but ideal for understanding how we could compare the data we got from Rome to real field conditions. I'll quickly show a video from this. So this is the barge we deployed on. As you can see here, this is an incredible resource. You can see that the flow of water past the barge is very identifiable. It was a great opportunity to collect high value data at a very accessible location. But as well as that, we had a lot of experience in applying best practice around operating in an environment with a lot of marine populations, including dolphins and seals, who had a great interest in the turbine. I think we demonstrated that there certainly wasn't any avoidance patterns. On the contrary, whenever we turned the turbine on, we saw a lot of activity nearby, which necessitated some pausing of operations to allow the dolphins to clear the area. But again, hugely valuable experience. And again, just talking about this site located near two towns, Portaferry on the left-hand side and Strangford on the right. And these communities, they've been seeing tidal energy turbines being tested at this location for probably over 15 years now at this stage. And it's a great example of a community that's very knowledgeable about this technology. I guess in terms of ocean literacy, this exposure to the technology has created this level of understanding that's been very helpful to us, both in terms of ensuring acceptance and buy-in for these types of projects, but also the types of activities that have been developed, including the upskilling of some of the local marine operators who supported us on this project, but have also been, active in and working on some of the big, the leading tidal energy deployments across the UK. So I think it's a real success story in terms of how this has been an incubation centre for companies like that. Moving on now, as we kind of continue our work in Europe, we're delighted to be a partner in a new project being funded by the Interreg Northwest Europe programme that kicked off formally back in March. This project is called Shines. It's led by Fondation Open Sea from France. And the purpose of this project is to identify how river and tidal energy systems can be taken up across the Northwest Europe region, across France, Ireland, Germany, the Netherlands, Belgium, and also Switzerland. We're one of 3 technology developers that is participating in this project. We'll be deploying one of our RaveGen turbines in Bordeaux at a test site operated by Ceneo. But as well as that, the focus of the project is engaging with a wide range of stakeholders, including communities, policymakers, and industry in the Northwest Europe region to understand what the potential is for developing this technology at scale across the region, how we can identify and develop a pathway for the uptake of this technology beyond the lifetime of the project. So we're just kicking off that project now, and as I said, it involves engagement with a wide range of stakeholders, and as part of that, I hope we can draw from best practice principles around ocean literacy to help these stakeholders understand the potential benefits available to them as we develop this project. And then just to go on from that, and maybe to wrap up and give some perspective on where we see ocean literacy being very important. I think part of this with us
3 minutes,
has been
Brendan.
perfect. Thanks, Ned. If I maybe reflect on our development of the RaveGen system, a lot of this and why the device looks like it does and how it's designed and fabricated and assembled the way it is has been a true collaboration with local communities and end users, and that two-way dialogue by true demonstration projects and working with them across a long period of time, that's helped us understand what can be done locally, what vessels are available, what local contractors typically present in these communities can what skills they have, and what will be accessible to our projects. That's ensure that we've designed a system that can be assembled using that local expertise, using the vessels and equipment that is typically available in these communities, rather than landing at a remote off-grid location and suddenly expecting to be able to get a very specialized type of crane or installation vessel. And also maximizing then how we can use local expertise to deliver these projects. And we saw, for example, during COVID in Igiagi, when our engineers couldn't travel there, the engagement and upskilling we had undertaken with the local community meant that they could carry out many of the maintenance activities we needed to do when we couldn't travel to the village. I think going on from that, beyond the technology side at a project scale, obviously engagement with these communities is a key part of these projects, and it's something I think ORPC we have developed a lot of competency in, but we've put a lot of focus in to ensure it's a fundamental part of our process, and something I think we're quite passionate about. We engage often and early with a wide range of stakeholders, and maybe an example of this is around fish monitoring. So when we've deployed our turbines in Alaska, we wanted to demonstrate that they had no negative impact on the local sockeye salmon population. The river in Igiagi, the Kivak River, is one of the most important sockeye salmon habitats in the world. So we undertook a very stage-gated approach to fish monitoring. We developed our adaptive management protocols around this, working with stakeholders to collect the data we needed to collect to retire any risks or concerns around this. And this involved working with federal agencies and scientific organizations, but also drawing from the long-standing local knowledge about the salmon migration and the patterns around that. And I think that's been a really good process that we've tried to replicate elsewhere, but Igiagi has become a really positive case study for that, and again showing the value of this wide range of stakeholders and bringing those groups within the project, and using the concept of ocean literacy to make sure people fully understand and can contribute to the de-risking of the project. And then finally, how we can communicate impact. We're trying to make a positive impact, both in terms of communities, energy security and sustainability, but then also on a global scale as well. And to give an example of this is some work we did with Queen's University in Belfast to produce a life cycle assessment for our technology. This is trying to use best practice science. It's published in for an academic community in an international journal, going through the peer review process. But this slide is one we use continuously because it can touch a lot of different audiences. We've the academic rigor in it. When we talk to investors who have maybe a high interest in projects that are achieving CO2 impact, we can quantify that. But then bringing it back to a community level and what they need. Their key metric is often financial, and it's the amount of diesel they have to use and have to buy. So we could, trying to convert that back into the metric that makes sense for them. And I think that's, something we've, across all aspects of our business, from performance to, environmental perspective, we try to ensure that communication is clear. So I'm going to wrap up there. But happy to take any questions, after Dennis's presentation in the questions and answers session.
Thank you very much, Brendan. That was really interesting, and just from my own perspective, it was great to see those small generators in action, and it's kind of very reassuring that I think our kind of pathway towards renewable energy offshore takes many different forms. And I suppose just a few of the things I picked out from their kind of thinking of the ocean literacy part was, you mentioned about how the demo projects that you had, for example, in Strandford Lough, were very powerful in just getting communities reassured about these technologies. But also, I guess, you mentioned the long periods of time that are involved in these, not just the technology side, but making sure that all your stakeholders are on board. As you said, you can't just arrive in a community and say, we're installing this thing. And for those communities in Alaska, you spoke about using local skills, contractors, and so on. So I guess it's that what's in it for us part. And it looks like your company is very kind of skilled and has great experience in that. And I think a lot of others can learn from that. As Brendan said, he'll take questions in a while. So please do use the Q&A facility that's available here to post your questions for Brendan and for Dennis. But we'll now move on to our second speaker today, and that is Dennis Istrati. And Dennis is the visiting professor at the National Technical University of Athens in Greece. He specializes in natural hazard engineering, and his research focuses on water-related hazards such as tsunamis, storms, and extreme flooding, and their combined effects on infrastructure and cultural heritage sites. And using advanced modeling techniques and large-scale experiments, Dennis studies how extreme events impact bridges, buildings, and transport systems. And his work aims to enhance the resilience of our built environment and also support the development of safer, more hazard-resistant communities. So, Dennis, it's over to you. Again, like Brendan, you have 15 minutes. So I'll just let you know at about 3 minutes remaining so you can start to wrap up. So, Dennis, it's over to you.
Great. Thank you, Ned. It's a pleasure to be here, especially among such distinguished speakers. And I'd like to thank EurOcean Foundation for organizing these nice events and making me part of it, because as you've noticed, I'm more on the coastal hazards and the marine infrastructure. So I'll try to give, as an academic, a slightly, let's say, different overview, a more generic one, so that our audience can have, let's say, an idea of what are the let's say the state of the art. So can you please verify that you can see my my screen? Can you guys see my screen?
Yep, we can.
Okay, perfect. Oh, that's good. So as Ned said, I'm a physics faculty in TUA. I also have a second appointment as an Alexander von Humboldt Fellow in Germany at Technical University of Braunschweig. And so to put things into place, I mean, most of us are aware who are working in this field that marine renewables are very important. Why? Because even the EU Green Deal has mandated that 55% of the emissions must be reduced by 2030 and then net zero by 2050. So the blue economy is actually playing a big role in that. So particularly as part of the blue economy, which involves, let's say, marine renewables, fisheries, tourism, etc., the role of the ocean energy, I would say, is like a threefold. First, decarbonization, circular economy, and coastal resilience. And of course, it can also complement other types of, let's say, renewable energy like wind and solar. Just for our audience who might not be very familiar with this field, there's a lot of information and data mapping, which has been produced in more than a decade now across Europe and in the US, as Brendan said. And so at this point, we know, for example, that there is technical resource potential for offshore wind in Europe between 2,600 and 6,000 terawatts terawatt hour per year, with most of it focused in Atlantic, okay, up to 6,000. So it's a huge number. Again, I'll try to, in addition to offshore wind, which is, let's say, right now is dominant, wave energy and tidal energy are the two other areas that also have progressed a lot. For example, here you see that wave energy is not up to 6,000, but it can reach 2,800 terawatt hour per year, which is pan-European. And then the tidal energy, there is a goal, recent resource estimate that they can reach up to 100 gigawatt of installed capacity, which means that it will cover about 10% of Europe's current electricity needs by 2050. This is the, let's say, the optimistic goal, with minimum to 40 gigawatt. So all these technologies are very important for our society. There's no doubt about it. For those of you who might not be familiar with offshore wind technology, I'm just showing here a snapshot of the most common ones, so you have a sense of what we're talking about. Depending on where we are, how close we are to the coast, it can be distinguished between fixed and let's say floating ones. And then depending exactly on the depth, you can also have, let's say, submodels of those, or for example, from monopiles, jackets, and gravity base, which basically changes the foundation. And of course, people ahead of us have already investigated that, and they have seen which one is more economical for each depth location. Similarly, some of the most common wave energy converters that have been developed to date, they range from point absorbers to oscillating water columns, attenuators that you see at the bottom, or for example, the very modular ones. And so if you can really keep increasing them and attaching them and produce more energy. So it's easier to scale them. Overtopping devices and oscillating wave energy surge converters. So these are the, as I said, 6, 7 of the most common ones, and each of them has its own advantage. So my point here is, my objective today is not really to go into depth of each technology, but rather try to find something, some common challenges and, let's say, common solutions for the whole field. So you're welcome to go into the reference section and find, let's say, details about this each of this, let's say, technology. Also a combination, let's say, in the last, I'd say, minimum 5 years, There is also an attempt to try to combine wave and wind energy systems. And the idea there is like, if you do that, then you have shared infrastructure between mooring, grid connection, etc. And you might also can have more continuous generation of electricity. And also, you might have heard there are also multi-purpose systems, for example. We now integrate, and this is the research has been done already for, I would say, 7 years now. But now we're in the implementation phase, and we go inside ports, and we installed inside breakwaters wave energy systems. You see an example on the right. So basically, you now can satisfy two purposes. You can generate energy for the local community, but also protect your port, which, you know, it's good for the blue economy, for fisheries, etc., and the tourism. Again, as you see, these marine renewables have a very critical role for our society, not only offshore, but really on the coast and inland. So some of the common technical challenges, irrespective of what is the specific technology that we have identified, and I think it's a common knowledge nowadays, is that we're very good as both in academia and the industry, especially very good with designing these technologies, some more, some less, but most of them, you know, they're designed with at the industry level for more simplified methods for service loads, you know, and so those ones make assumptions so that we can produce quick designs. And so in harsh environments, many times I would say that these devices can fail, not only due to high cycle fatigue, but also to, let's say, extreme hydrodynamic loads, slamming effects, which we typically cannot consider very accurately in our designs. So harsh marine environments, this is something that's a big challenge worldwide at this point. Anything with natural hazards, for example, in Asia and in Indian Ocean, they have effects with earthquakes, so fixed structures, the fixed wind turbines, they're afraid of these issues as well. So we always need to think of what is natural hazard that these structures are exposed to. Grid integration, again, there's some common technical challenge there. Why? Because it's typically this, in order to increase the potential of wind or waves, you have to go far from the coast, and then the cost increases. And also, sometimes because you are not in the core area of the network, then you might be in an area where you have grid congestion and so high transmission losses. Technology reliability, that's also very important, because issues can stem from, for example, from mooring failures, dynamic cable fatigue, and so this is basically showing us if the device which we have, let's say, developed is going to be there and perform the same way for the next 50 or 70 or 100 years, depending what we are targeting. And the fourth one is the resource identity. This is a very important aspect, because local scale resource mapping is very hard. It's very, let's say, sensitive to local conditions, to nearshore hydrodynamics, etc. Of course, this depends on the type of technology. For example, tidal systems that Brendan was talking about, they're 100% predictable if you know the tides, but on the waves and the wind, you have more variability. So again, it's but overall, these are the four technical challenges. Now, because as we said, it's not only about the technical challenges, but rather what it costs to our society and our environment. This is the scope of these workshops, and this is where the European Union is moving towards now, is that we need to look at what are the environmental challenges here. You know, what are the effects? And it has been recognized already that ecological impacts can be very important. So there's a lot of push there. For example, offshore wind turbines can generate underwater nodes, benthic habitats, create collision for marine fauna, etc. So that's something we have not traditionally investigated. You can have cumulative effects. Why? Because now in the North Sea and some areas you have multiple farms next to each other. So now the environmental impacts are even more important. Also monitoring gaps, which means we don't have enough data from gathering ecological consequences, and this can be expensive, and it's also not standardized. So the lack of standardization is a very big problem in many of these subtopics that you will see later. On the socioeconomic side, workforce development, this is an area where you need special skills. You need a lot of education and training, and so this is something that I would say is one of the major things. And then public acceptance. You know, let's say once you get to the point where you have developed technology, as Brendan said, you have to spend a lot of time to convince and let's say get on board the local community, so that it's more easier for them to accept this new technology. Now, other three areas which we also have identified in terms of challenges: policy and governance challenges. Now, as an academic, I tend to focus more on science, but really These are so important technologies, and they can influence so much our lives that it's very important to consider policy and government issues. So, for example, regulatory fragmentation is a big thing because each country can have different procedures, and now it can delay one, let's say, developer to move to another and apply technology to another country. Permitting delays can happen very often, and approvals can take years, which delay, and again, you can have financial consequences. And then policy uncertainty, like you've seen and you've heard on recently about the subsidy changes in subsidy schemes, which then makes it harder for investors to come and invest in these technologies. Cross-cutting challenges, funding gaps. This is also very important because we always need, it's hard to find private capital. So we need to ensure, for example, that either European or research funds are available for the industry together with academia to develop new research. Knowledge transfer. This is a very practical challenge that we have really faced in recent research projects because there seems to be a disconnect between academic research, industry, and policy frameworks. And so that's why when you are trying to either as an academic develop new research, it's very important to involve the industry and the stakeholders early on, because then they're more familiar with your ideas, they can support it, and jointly can develop the best possible outcome. And then integration challenges, of course, system complexity. This is something that, again, I think the community is looking into. And then data harmonization, which means, as I mentioned earlier, there is absence of standardized data sets for resource assessment, environmental monitoring, and impact analysis, which again makes it difficult for people to benchmark their, let's say, technologies. So this is the negative part, but let's see what are the positive things and what are some promising solutions. There are many more, but these are just some ideas I want to share with you guys today, generic ones. The good thing is that, academia has done its part, the industry has done its part, and so we have many advances when it comes to really try to understand these effects. So we have new next generation high fidelity tools that can help us really understand how complicated, floating, flexible, and deformable structure interact with this with extreme waves. We can look at very extreme scenarios which we have not looked in the past. For example, how ice impacts this type of structures, or you have accidents like you've seen in the last 6 months that there was impacts of, let's say, ships impacting monopiles. So until very recently, we're not able to do that, but in the last 2-3 years, such methods have become available. So this is important to be aware of it. High-performance computing and AI. That's something we keep hearing everybody about AI, but we should not forget that all this is possible because the European Union has invested in high-performance computing. So the EuroHPC, which leads the way in European supercomputing, makes it now possible for both academics and the industry to really get access on the system and try their technologies. And this is like super useful, which at this point we have not fully leveraged as a community. So for consultants out there, keep an eye on these ones. There are specific calls that these supercomputers have, and so they are dedicated to certain projects, but then they will allocate maybe 25% of their time annually to, let's say, support new ideas, support new projects. So you should really take a look into that. It's super helpful. But with such tools, you can now, let's say, develop huge models. You can do extreme condition analysis. You can do simulations that otherwise it will not be even feasible to do and analyze and predict what will happen in the next 100 years, for example. So this is thanks to, let's say, this hardware revolution. Also, the European Union has Ocean Digital Twins. This is a very important initiative that they have implemented in the last at least decade. So here I'm just mentioning three projects, like the editor, the European Digital Twin Ocean. So basically, what the European Union is telling us, hey, the ocean is unpredictable, it's so complicated. Let's try and build replicas of what we have in real life. And so, for example, CCLIM and MIRE, these are projects that can bring really transformative tools. Why? Because if you have, and your wave conditions very well, you can have digital replicas, then you can have an optimized site selection, resource assessment of your technology. You can have an enhanced design and survivability. And the nice thing is that it has dual products, this type of project. What do I mean by that? They have tools for experts and academics and consultants, but they also have nice visualization tools for the general public. So in addition to the technical aspects,
3 minutes.
Yes, thank you very much. I'm almost done, so that's good. But in addition to the technical aspects, it's really, it enables for the first time for the communities to go and do scenario testing, for policymakers to go use these digital twins and say, hey, what are the trade-offs if, let's say, between energy production, environmental protection, economic goals? So you can analyze different scenarios when you have these digital replicas. Then also you can do what-if simulations. For example, banning fishing in wind farm zones versus having multi-use designs. Again, such digital twins allow you to do that. And ultimately, the very important thing is that can help gain the public trust, because at this point, as I said, communities really need to be part of let's say adapting these technologies to make them successful. And now we're going to the most, I would say, less scientific side, but I would say sometimes even more important aspects, which is really to go into co-development of ocean system with stakeholders. And why do I suggest that? Because at the end of the day, what we want to have enhanced project viability and public acceptance. And sometimes this is difficult if the local community cannot see direct employment benefits, direct local economic benefits for that area. So we need to get them involved. Also improve decision making through local knowledge. For example, if you want to go build a new technology or test it somewhere, fisheries associations and fishing vessels operators have been very helpful stakeholders before we deploy. So it's always good to try and learn from local people. And then policy alignment and regulatory streamlining. This is also an aspect that the European Union is putting, let's say, is prioritizing. But at the end of the day, what we can achieve with that is that we can really reduce conflicts and barriers by the time we get to the point to really implement and test the solutions. So because ocean literacy, at the end of the day, is an underlying concept, or let's say an important parameter in order to, let's say, overcome some of these issues. I have identified here two types of benefits to the marine renewable sector, but also to society itself. So by let's say promoting ocean literacy, we can build public acceptance and support. We can bridge science, industry, and public understanding, create informed stakeholders, and develop skilled workforce pipelines, which I mentioned earlier. That was one of the challenges. On the opposite, the societal benefits of ocean literacy is that we can empower responsible choices, improve well-being, promote informed decision-making, and generally, ultimately, achieve cross-sectoral coordination. So if, I mean, I know I've showed a lot of information, but if you have to keep, let's say, 5 only points from my presentation, are these 5 here. So I think based on the expertise and the experience we've had with different technology providers and with research projects is that we need, at the end of the day, to keep doing research and development. Keep investing both on, let's say, new research technologies, new type of projects, but also dedicate funding for high TRL for actual demonstration. Because at the end of the day, that's the only way to prove the reliability and the survivability and performance of the system you're recommending. We need to invest in ocean literacy. Why? I explained it earlier, but the question is also how. We can embed in education, we can do industry training, and then of course policy as well. And at this point, as far as I know, there are not particular metrics for impact assessment of ocean literacy. So that's something we can invest in so that we can standardize the process. Collaboration, as I said, we need to try and share more data, cross-border demonstration project, and then have the academia working together with the industry and policymakers. Adaptive management, which means that, as I showed, like AI, new, let's say, sensing systems, digital twins, can help us do real-time environmental monitoring and, let's say, performance assessment optimization of the device. And then at the end of the day, the policy. We need to align our national strategies with the EU targets. So then it's easy for one technology that has been deployed, let's say in Denmark, to come and be deployed in the Mediterranean Sea, in Greece, Italy, etc. And that will incentivize more companies to really try to expand their technologies. So with that, I would like to thank, and I'm here to take any questions. Thank you.
Thank you. Thank you very much, Dennis, for that quite comprehensive coverage of different areas around the renewables sector. So I think it's time now for some questions to pose to our speakers. So please do keep the questions coming in the Q&A part of the platform. And I see there's a couple of questions there already. But I have a couple of questions here of my own, which I'd like to start with. So I'm just going to give Dennis some breathing space. He's been talking for a long time. So we'll address our first question to Brendan. And Brendan, your presentation highlighted very strong community engagement and stakeholder involvement in a number of your projects. And from the experience of the company and your own experience, How does enhancing ocean literacy among these stakeholders help facilitate smoother project developments and deployments? And you hinted at that for the Alaska community and also on the Strandford Lock one, but maybe you can give a little bit more detail on those.
Yeah, thanks, Ned. No, I think for us, like this community engagement, stakeholder involvement, it's not just a tick the box exercise, that we need to do, and need to show to get the project through the, our permitting processes without opposition. I think we place a lot more value in the engagement than that, type of exercise. We see it, as ultimately making our projects and our technology better. And I think our experience has borne that out. So I guess, like, as we try to, the benefit of enhancing ocean literacy really supports the value we get from that engagement. If the community has a better understanding of how our technology works, how it can benefit them, how it could interact with the marine environment around them, ultimately it provides us with better feedback on our projects, on our technology, and it also allows us to maybe, capture more of the local knowledge and skills that are available to us. So yeah, I think we see that having that enhanced ocean literacy really has a positive feedback effect. And, again, both in terms of the projects we're developing local to those communities, but also how that feeds back into improving our technology so that as we roll that out in more places, it's highly suitable then to increase that uptake.
Okay, thanks very much, Brendan. And Dennis, I'd like to ask you a question. So from Brendan, we've sort of heard on maybe the community side how to kind of smooth those transitions of bringing in new technologies. But near the end of your presentation, you listed a number of benefits of ocean literacy to the marine renewable sector itself, from building public acceptance through to developing a skilled workforce. So if you were to prioritize those different benefits in the sector itself, which would you say is kind of the most important, and why do you think that?
Yeah, thanks for the question, Ned. I mean, that's exactly to the point. For sure, I had a bunch of them, but if I had to choose only one, I think it depends also at what stage the particular community is. So, for example, now in Greece, which we want to, let's say, I'm not going to talk in the North Sea because North Sea is already advanced, but let's say in Greece where we're trying to bring this renewable energy, you have local communities that really don't accept. They're not familiar. They don't know what it is. They're really afraid because they are afraid. I have my way of life, and I'm going to see tomorrow on my coast some scary things. It really destroys the local way of life. And so for communities that really are not that advanced, have never been exposed to such technologies, the public acceptance, in my mind, is the most important. And to achieve that, you really need to invest time early on, bring them on board, maybe start them young. Like you need a long-term plan, first of all, to do that. You need a long-term plan as an institution, as a community, municipality, to say, I'm going to go invest in education, future generation, have them go build some models. Like there is now, I think there's a network initiative where they're trying to teach young generation and just go make and stand some offshore wind turbines so they get used to them. So stakeholder engagement, ocean literacy, these are the very important things for communities that have not been there. Now, the next step, however, once you achieve that, the more practical one is that you need, the skills and the people to do it. The good thing, because European Union allows transborder, I think that becomes less important at this point, because now you have companies from North Europe which can come to Greece, bring some of that knowledge and so the workers. But I think, yes, I would prioritize the public, let's say, involvement, literacy and awareness, and then the working pipelines.
Okay. Thanks very much, Dennis. I think that kind of resonates a little with what Brendan was saying as well. So just going across to the Q&A, there's a number of questions there, and we'll see if we can get through a number of them. So the first question that was posted here was for Brendan. You mentioned that during COVID, the community in Alaska was able to support maintenance of the turbines when the specialists couldn't easily travel. So how much of this initiative implies citizen science? So were the citizens trained at any point? And is there a plan for residents to take 100% ownership of the technology and its maintenance in the longer term?
Yeah, I think maybe to elaborate on that example, like we had been working with the community for a number of years in advance of COVID hitting, and we had been, relying on them to provide, hands-on technical support to the project. So rather than us, coming in with, a full ORPC team to fully execute the project, we, developed and installed these projects and had operated them in partnership with the local community. The community was already running its own grid. They had their own, electrical cooperative to manage to manage that. So we needed to firstly work directly with them to integrate our systems within that grid. But then, where we are in such a remote location, it makes sense to utilize the other skills that are there in terms of boat operators, welding experience, just general experience with construction equipment that we needed to assemble the devices. So really it had become just our natural way of working. It wasn't maybe necessarily a specific training program. It was just utilizing the local skills to execute the project. But that then in turn that enhanced those skills so that, in this example where we didn't have the ability to travel, there was that capacity to undertake some of the maintenance activities. And I think scaling up, I think that becomes very important. We're doing these initial pilot projects, but we're a small company, and in terms of a business model, I think it makes more sense for us to develop local partnerships who can operate these projects rather than us trying to, do this, hopefully as we expand globally. So again, there's a local benefit, but it also, supports our own business model.
Okay, thank you very much. And that addresses one of the other points I saw in the Q&A, the idea around scaling up. And I think, as you said, you're just one company among many, but if you can kind of give the local communities responsibility as well and get them to be very much involved, that's a real positive. Dennis, I have maybe slightly more technical questions here for you. First of all, could you maybe speak about the energy efficiency of the wave and tidal energy? And then also some of the challenges around the noise pollution part and how that can impact on other ocean species.
Yes, thanks for the question. Now, to be honest, when I was putting the presentation together, I avoided intentionally to show efficiency of systems, and the reason is that each of them is very particular, but I can give a range. So, and the reason, because as an academic, I'm not supporting one particular. I don't have a company. I'm not supposed to support one particular system or company. That would be an FCAN from my point of view. But I could give to the audience there are references at the end where you can find at the end of my slides. In the references, you can find dedicated reports for each of these technologies. I could tell you that the minimum that I have seen from, let's say, in the wave energy, between 15% up to 50%. But again, it depends on the characteristics of the wave energy converter. And so keep in mind, this is a very good, let's say, percentage, I would say, especially if we consider the uncertainty that it's associated with where you don't get the waves or you don't get the wind when you need it. And so this is just to put in a range. Now, regarding the second question, I don't think at this point it is solved. I just can say that traditionally, when we're designing these the structures, we were really trying to make them withstand and make sure produce the energy they want. These were the criteria we wanted. Try not do no harm generally, but there is no standardization telling you, hey, don't go that big of offshore wind pile because you're going to affect the fisheries. The European Union has established this initiative at least in the last 3-4 years, and so I can say that they're relevant Horizon Europe project right now. We have one of them, I mentioned the Miria one, where actually we take one offshore wind farm from the North Sea, and we're going to go and quantify the effects, the noise impact, and other and how it changes, let's say, for example, the erosion patterns, because once you install them, you change erosion patterns because interact with your waves, and now you can also change the local ecosystems. So I would say there are at least 4 or 5 research projects, multi-million research projects from European Union to look at this exact question. So I apologize, I don't have the answer yet, but if you ask me in 2 years, probably I'll have the answer.
Thank you very much for that. And I do know that there's a lot of investment from the European Union on looking at underwater noise sources. So I'd recommend our kind of questioner to go there, because it's not just the offshore energy that's creating anthropogenic noise. There's lots of other activities, and there's a lot of work in Europe on that. So I'd encourage you to kind of go and explore some of those projects. Another question here, this one going back to Brendan, is this questioner is from Texas, where the grid is regulated in that state. Could you elaborate a little bit on smart microgrid solutions and your experience of regulators' buy-in, especially in relation to the United States?
Yeah, Rick, really interesting question. I suppose the example I gave of Igiagig is maybe one that's very, is specific in that was an off-grid community, so that hadn't been, connected to the grid. We did have a FERC license, being one of the key regulators in the US, and the village actually, rather than RPC, was the entity who secured that license. But I guess thinking of other types of projects, that we're looking to scale to, where our systems will be connecting into communities that already have a grid connection. I think we still see benefits to those projects, even where there is already a grid connection, in terms of improving the resiliency of those communities' energy systems. So for example, we were undertaking a very interesting project with the community of Eastport in Maine, where we've had long-standing testing of our devices, and we have a preliminary permit for a commercial site close to that community. And as part of a project with the local grid operator and a number of US federal research institutes, we actually were studying how you could, develop a microgrid with this type of community that is grid connected, but often has, this is a coastal community at the end of a long transmission line. They had resiliency issues. They were prone to things like blackouts. So as part of that project, we studied, different designs of how we could integrate, in this case, a tidal energy project into that community, be it direct grid connection or also like behind the meter microgrid solutions. And we did see a lot of benefits in terms of improving the resiliency of that community using these systems. And there has been some interesting research carried out on this topic within the US. The Pacific Northwest National Laboratory did a study looking at the benefits of marine energy within a grid, and that can improve things like the balancing of other renewables, where you have intermittent renewables like wind and solar, under that can be supported by very predictable tidal energy. But then even, in terms of how you design some of the local grid infrastructure and some of the benefits you can have to extending the lifetime of those. I can drop that study in the chat, so we can see, that there is also this strong business case for incorporating marine energy systems, within grid systems, either direct integration with the grid or as part of let's say a co-located microgrid.
Okay. Thank you very much, Brendan. We just have a few minutes left, so I'm just going to have one question here, and I'd like you to try. It's going to be a big question, but I'd like you to kind of keep your answer fairly focused. So I'll just ask Dennis first. The question here is kind of, you spoke a little about the efficiency going from 50 to 50%. And we also saw, I think, from Brendan, that when they replaced the diesel generators, they had a lot of benefits, both financial and on the carbon side. So if there's the kind of those well-documented benefits, what's blocking the widespread transition to green energy, such as this offshore energy, but also other forms of renewable energy? Because I know, Dennis, one of the challenges you said was just getting private equity in this sphere. So if we have to do this transition, so what are the blockages? Is it around the value of commodities? Is it politics? Is it consumer buy-in? Kind of what's your kind of 1 minute take on this question? So Dennis, I'll ask you first, and then Brendan, you can be thinking about an answer.
Thanks for the question. 1 minute, it makes it impossible. I think all of this together So, for example, people are afraid of sharing, things. The coast, the ocean belongs to everybody, and so I think we need to develop. First of all, people are not informed. Second thing, people like to do what their common, let's say, activities. Fishers like to do what they do. Offshore want to do what they do, and so there is a lack of let's say of this mentality that we can share things. That's why we start talking about marine spatial planning. So marine spatial planning is important, and we need to start thinking about multi-use of the same resources. And so right now, for example, there are some offshore wind farms that they are trying to attach aquaculture, for example. So that is a way to make everybody happy. So this is one of the reasons. Other reasons that we see is that there is no one institution that will be in charge and making decisions, and say, hey, this is how we proceed from now on, and then you have multiple institutions claiming, and so then the public doesn't know who to trust, correct? So this is another thing. Another, I would say, factor that we need to consider, there is not always transparency. Sometimes, municipalities take decisions and then the public is informed later. So it looks like more like a checkbox instead of engaging people early. And so I think if we sit at the table, we have a clear path and a long-term plan for the next 20 years, 30 years, and we put down, okay, what are the objectives of this specific community for the next 20 years? Which societies, or let's say scientific areas, or let's say in industries are being affected? So let's find a common place for everybody. I think that's what we need to do.
Thank you very much, Dennis. And Brendan, quickly, would you add anything in addition to what Dennis has said there?
Yeah, I think just, I think we now have, maybe more tools or more solutions available to us to achieve these decarbonisation goals. I think in the ocean energy sector, we've had a huge amount of investment already into these solutions and testing them and bringing them to commercialization. There's been a lot of efforts to develop good frameworks for de-risking that technology development. So I think a key focus now is supporting the scale up, going from individual devices to arrays of devices, both to help the commercialization of these technologies and companies like ours, but I think also to collect the data required to help de-risk these to the receiving environment, understanding, at farm level, retiring some of those risks, be they environmental, potential conflicts with other marine users. I think we now need to get to those larger scale developments and understand, how they interact with local communities, how they can benefit local communities ultimately. So I think that's, support for those projects will be, an important step to overcome those barriers as we scale.
Okay, thank you very much, Brendan. And I'd like to thank both of our speakers today for very interesting presentations. And I really enjoyed the Q&A. And I know we only scratched the surface in terms of this, but I think there was some messages there on really how important it is to engage local communities and bring them on board, because if you don't do that, you're fighting an uphill battle. And there was a lot of other, I think, very thoughtful insights there today. But unfortunately, we've got to the end of our hour, so we'll bring this to a close. So just before taking my leave, I would like to remind you, first of all, that the whole webinar series is available on EurOcean's YouTube channel. So there's a number of previous events there. So please go to EurOcean's YouTube channel to see that, or you can tell your colleagues you'll find this one there probably in the next few days. And one last announcement is that if you happen to be in Cork in Ireland for the European Maritime Day, please just go one day ahead, because EurOcean, the EU for Ocean initiative, will be hosting an event called Coastal Success Through Ocean Knowledge the day before the official EMD activities get started. So put that date in your diary, and please follow the social media on EurOcean to find out more about that. And I think Ruth or Sarah will actually share an image and a link in the chat here, so as you can find out about that and put it in your diary. So that brings us to the end of today's seminar. Thank you to the speakers, and thank you to all of the participants and listeners out there, and for the questions that you posted as well. I hope it was as insightful for you as it was for me. And with that, I'd like to thank everybody again, and have a nice rest of your day. Thank you.
Thank you. Bye.
Thanks, everyone.
Thanks so much, Ned and Brendan and Dennis.
Okay,
I think
our
that was
pleasure.
very enjoyable. The questions were very interesting, and yeah, the discussion, the hour went fast.
It did.
So-
It always does, I think.
Yeah. So thanks so much, and we'll be in touch as soon as we have this up online to let you know
Okay,
when it's
perfect.
available. Okay, have
Okay.
a good rest of the day. Bye-bye.
You too. Bye, everybody. Bye. Bye.